So welcome, thank you. Another beautiful day, beautiful Poland. Very happy to be here. Today we're gonna talk, or I'm gonna talk about bridging the gap between industry and academia. So that's the theme, but before I get there, I wanna talk a little bit about the context, so my journey there. So basically I studied machine learning, finished my master, then I worked for a search engine company, first as an NLP engineer developer, later as the head of the research department of that company, doing all sorts of stuff, so sort of industry experience. Then I realized I like other things too, so I finished my PhD, which was again computer science and NLP. What came out of that is also some software which some of you may know, like GenSim. So I created and we maintain a few open source packages. So some of you may know me through the open source work, which is fun too. We like that stuff. But primarily after finishing the PhD, I started a company called Rare Technologies, where we build systems, machine learning backend systems, so some sort of analytics, recommendation engines, search engines, all sorts of stuff across all sorts of industries. So you will recognize some household names in there. So we have lots of clients and it's very exciting, interesting work. But it's not the theme of this talk. So let me just move ahead. Basically what we do is this intersection between engineering and research. That's kind of our theme. We like doing that. A lot of it is some of it is primary research, a lot of it is applied research, and we collaborate with universities. We realize we have this large overlap between research and, let's say, with the academic world and then with the industry world. So we launched Incubator, which I will talk about quite a bit today, as a sort of bridge between these two worlds and how that worked for us. So that's another thing we do, and yeah, in my spare time, I try to have a bit of life. Doesn't happen often. So since 2009, we've been living in East Asia. Our last base was in South Korea, a little island of Koje. I don't know if there are any Koreans here. Probably not. This picture is actually from Thailand. So yeah, we try to have fun. When it rains, it really rains. So you see the flooded streets, and the zoo was flooded as well. And our neighbor had an alligator in their backyard in the morning because all the animals escaped. So stuff like that. Why I'm mentioning this is that's sort of my theme going into it. I wear a lot of hats. We do research and I'm a business owner and we have open source and there's this little life component. So that's kind of where I am. And when I see the friction or the issues that everybody knows that there's a gap between industry and academia, it's a big theme. Lots of money is being spent on how to solve it. Millions from EU funds and so on. So it's a hard problem. So this is just my little note, my little observations. All of it obviously will be my opinion. And I identified two main friction points that I would like to talk about today. So the first of them is about risk. That's a big thing in business that people sometimes don't recognize in academia. Businesses, if they could choose, they would stay the same forever. They wouldn't change. They don't want any novelty. The processes are there. Everything should be repeatable and stable. That's the goal. The fact that they don't do it is because they can't, because of competition, but that's what they would like. They hate risk. So that's something to keep in mind. And in academia, it's kind of the opposite, and that creates the friction. You want to be novel, creative, and innovative. So let me give you one example of the collision. So in research, researchers want to build end-to-end systems and complex systems and kind of hide the complexity and just get to some good number at the end. So there's an example from some paper. It doesn't really matter what that is. What I want to highlight is that the previous best score was 92.3 and now they got 93.2. And that's a big deal. That's what researchers kind of like. And everything, how it gets there, it's this kind of black box ideally, which is exactly what the businesses don't want. Having a magic box in the middle of your system, that's the nightmare for businesses. That's the unmanaged risk. And this sort of chasing of state of the art, that's the SOTA there, is a common theme. And there are a lot of issues that come out of it. And I'm going to be mentioning some of them. Basically, what we often find out, because we see all these papers coming in and we want to see which ones actually make sense, because it all sounds amazing and it's all revolutionary, but when we actually look inside, we find there are issues with the implementation and all sorts of details, so it's unreproducible, a lot of it. And I'm kind of sad to say, it's a little cynical, but when I see a paper and I see another SOTA result, I'm kind of, oh no, not again. I've been punched one too many times, so I built this defensive reflex, and I'm kind of not very excited by SOTA results. What I like to see is a paper that says we found a hack. For me, that's the ideal thing. So somebody actually looked into the problem, they understood the structure, and they found a shortcut. So that's the kind of papers that are actually practically useful, that excite me, and that can be applied to business, and that's what actually works, as opposed to, say, running a grid search on 2 billion parameters. That's it's kind of great. It gets you a bit better results, and if you're Google, obviously, it may every percent count. But most businesses, nobody will shout at you if you're 2% worse. They will shout at you if you don't understand the problem or if you can't explain what's happening. On the right, there's kind of continuing the theme. There were some seminal papers in reinforcement learning. And when OpenAI, the initiative, looked into them, 6 of them actually had some flaws, and some flaws were serious enough that the SOTA numbers were actually wrong. And this happens a lot. I gave this a name because we see this over and over. We implement a lot of papers, some of it open source, some of it is just for clients, so you wouldn't know that we did it, but we do it a lot, and this happens so often that I gave it a name. I call it the mummy effect. And it doesn't only happen to, let's say, junior researchers, this unreproducibility. When we implemented the paragraph vectors, the doc2vec, some of you may know, again, that paper was unreproducible, and that was Google Brain. So this was a large company, but still couldn't reproduce. This is more recent. I blacked out the names and the context because the jury is still out. It's possible we did something stupid, but this is an email that we sent to some Facebook researchers. We're trying to implement that paper, compare it, see how it works, and we couldn't. So the mummy effect is, it looks great, but the moment you touch it, it crumbles to dust, like an Egyptian mummy. That's why I call it the mummy effect. So, and this is, for me, a source of a lot of frustration. And before I get to tips, so building the bridges, what can we do? One more little note. Another thing that's frustrating for me personally is actually hiding all the complexity behind some final metric, like final number, aggregate numbers. Because more often than not, something is going wrong in the pipeline and people don't even know. There were some good talks yesterday about this interpretability and so on, so I'm not gonna go too deep, but I just give you 2 examples here. These are real world examples. So maybe some of you can spot the error here. Word2vec is a specific model. It's to be trained on sentences, and each sentence is a list of tokens. I don't know if I can show, but you see the sentences is actually each sentence is a string rather than a list of tokens. And in Python, this will work because you can iterate over a string, but it won't give you tokens, it will give you the individual characters. So this is an error that happens often. And people just run the pipeline and they don't even notice they're doing nonsense, complete rubbish. But it kind of works, but they never look inside and they get some numbers. That's a good case because the numbers will be lower, so they'll try to think like what's going wrong and maybe go back later. But in some cases, like on your left, on your right, building some name entity recognizer, and again, this researcher just shuffled everything, so it was just garbled data, and through some multiple errors that they made, they actually reached 100% results. So the results were great, so they never actually looked what's wrong, but it was garbage all the way through. So this happens a lot, not just to juniors, but it happens to everybody, unfortunately. I've been around long enough that I know this does. So what can be done here? Just, I guess, pay attention. But what we always encourage, for example, our interns and people in the incubator is start simple. This may sound trivial, but just sprinkle the pipeline that you're running with some logs. It's really simple. You don't need to learn framework. Unit tests are nice, but it's unrealistic. In academia, just double the work. You write the code and you write the test, but you don't know will end up, so then you end up doing it in 2 places at once. Not gonna happen. But this is something else. I'm talking about just maybe replacing the comments you have, just put it in a log and be concrete in the log. So show a few examples of what data flows, like pick 3 of them. I think I have an example here. So it's super simple. You build a dictionary. So instead of saying I built a dictionary, you just say it has this many items inside, and you show 3 of them maybe. And it sounds kind of trivial, it kind of is, but this is another real example that in one of the projects, the system was accepting text tokens, but instead it was getting some binary data, so like images or compressed files, and nobody noticed as usual. But when you actually looked at the tokens, you saw it's garbage, and then you could go back. So humans are still the best anomaly detection engine. So just give them the input just to eyeball the results and see maybe that something's wrong. Even if a unit test couldn't catch it, like nothing's wrong with it, it's still text. Who cares if word2vec has 50, a vocabulary of 50, because it's characters instead of 50,000. That's fine, but a human will immediately catch that. So really simple, start simple, and this will already do a lot of good. Industry will thank you for just doing this really simple thing. Second thing is also simple, not as simple, but still fairly straightforward. Interactive demos. I think there were also some great talks about that yesterday. When you put something in front of people, they give you feedback, so that you will see more eyes make all problems shallow. It's like a parallel to the open source, more eyes make all bugs shallow. And people will show you where it doesn't work, and it will also drive you towards trying to understand what's wrong, because if you get a bad result, it will naturally nudge you towards why did it happen, which is what's missing in the papers, in the analysis. So this is a great way to do it. How do we do it? Again, to be concrete, little web demos, so I don't know, it's probably too small for you to see, but it's not that important. Just some fields, you click a button and something appears. That's enough for a lot of people. It can be a lot of fun. They can show you the errors, something's wrong, something's stupid, and you will learn something about your, whatever you created, the system. And release reference implementations. That's the one on the right. That's like a well-studied domain of finding similar vectors in high-dimensional spaces. And it's been studied for decades, so I thought, well, if you look on that little rainbow and the butterfly, that's what I expected that I will find, that out of all of this research, there's some useful stuff that I can try, maybe compare. And then what's next to it is what's the reality, or what was the reality in, I think, 2015 when I did this comparison of the various approaches and their implementations. And there was just like one library that actually worked, 1.5. The other one just failed if you gave it too much data. So that's really sad. The second friction point, so that was sort of managing risk. So the problem with quality, okay? You look at something and you cannot trust that it's actually correct. That's very upsetting, because then the business has to sort of do the research, do the evaluation, and then the implementation and practically everything, and that's just too much work. That's not great. So that was managing risk. The second part is ownership. There's little, to be fair, there's little that academia can do here. This is more on the industry. Here you see some motivating slides that are very tongue-in-cheek, very inflammatory, I would say. Basically, people complain that they don't understand why some research happened, what to make out of it, why is it so unintelligible and strange. And the source of that is, of course, publish or perish. I don't know how many people come out of academia are familiar with that, but basically the goal is, what you have to do as an academician is to publish and get citations. That's how you advance in your career, which results in a huge amount of papers that nobody reads. I can see some statistics there. It's write-only mode. And also it promotes this sort of little incremental steps, because you get more publications if you publish each step of the way rather than doing it properly. So again, we're back to the quality. It's related to that as well. So it's just too much stuff. Nobody can really follow what's going on archive anymore. It's just stressful, annoying, and most of it is crap anyway. So That's tricky. What they say is that every great library is built on the ashes of somebody's academic career. So that's, you see Travis there. Some truth to that. I think it's changing a little, like the tools are getting more recognition, at least by, if you measure impact by how people use it. What you see, that graph on the right is the citations of GenSim, so that's the little library. It's not rocket science, but it's still got like 700 citations peer-reviewed over the years. So it does help a little bit, but obviously there's not much that people in academia can do. The only thing that really can be done is to better explain the results, to put them in context, spend some time on motivation, why am I doing this? And if the publications don't actually support this, they only have 4 or 6 pages in some journal, then do a little blog post on the side, do it differently. Find some other modalities of how to present it, again, like the demos, or publish some blog post or a notebook, Jupyter notebook, and so on. Again, this was beautifully covered by, I think, Catherine yesterday, so I'm not gonna, I wanna speed it up a little because I have stuff I wanna show you at the end. So, and again, yeah, getting the problem right and getting the context is more important to almost everyone than the SOTA number you get at the end. If you do the error analysis and you provide some insight about why this should work, it also drives further research because they can build on that rather than just, here's a number, it's better than the other number, I win. How we do it, we try to do this stuff of taking various papers and just comparing what works and what doesn't. Kind of picking up the pieces. Again, there was a talk about how we're in the middle of a revolution. Yes, we are. But there's a lot of corpses around, sort of. So we have to pick up the pieces, see what works, and what was just dust, just the mummy effect. So, and a lot of our students in the incubator are involved with this. And I think it's beneficial to them. It's beneficial to academia. It's beneficial to industry. So it's like a win all around. But primarily what can happen here must come from the industry side. Because the incentive really is to publish. That's how you advance the academic career. And there's little that people in academia can do about that. So what can happen from the industry is we can teach the students or the prospective researchers the skills that we think are lacking, that bring this anxiety from low quality results and just abandoning the research after it's published. So it's risk for the, do I pick it up? Nobody's touched it for years. And so on. So there's some continuity. Sponsoring hackathons, meetups, conferences, the standard stuff, open source. So again, we're trying to do all of that. Coming back to our incubator, it's really working well. I would say this is probably the main. We only launched the incubator in 2016, so 2 years ago. And I think it's been great. The students love it. We have more than 20 graduates now from the incubator. What they do is they collaborate on projects. We help them, we teach them the tools such as how to share, how to do organized tasks, use SSH to use our servers and the servers we provide for them in whatever Google Engine and Azure and Amazon and these other services. So sort of practical skills, but also how to present their results, do these little demos and see that it's not really difficult to add a little log line here and there, and that it really helps. They see that the research that they did is better. They can trust it. They're more proud of it. So it's great for them. It's great for us, selfishly, because three of the graduates we actually hired, so they work for us. So it's a sort of HR pipeline, to be honest. And I think it's also great for the academia because, again, a lot of these people go back and cross-pollinate and share their knowledge with their teams. Yeah, and we're sponsoring some conferences and lots of other stuff going on. A little note on the competitions. This, on the face of it, it looks like a great thing. It combines the industry and the academia as well. You work on practical problems, but you apply your machine learning skills. I listed a few things that are not so great, because it turns out that a lot of the winners, it's basically about fighting the rules. You have to find the little where it leaks, where there's some leakage in the data, and that's how you win these competitions. And I think the real heroes here are the people who actually do the tasks, who prepare the data and define the rules. Because that's a lot of work. It's the most work. It's also super useful to have these data sets, but they're at a disadvantage because against them is a huge horde of very smart people who will try to find faults in what they did. So there's little chance they can do it properly, but their work is, I think, amazing. It doesn't really teach the skills that I mentioned with the collaboration and interpretability and how to present and so on. So for us, this is not the critical. It's great for what it does, but it's not the solution to what I'm talking about, the gap between the academia and the industry. And that's on the right side is the same thing in a more diplomatic way by Netflix. So they had this prize, it's, what, 8-9 years ago, where they gave $1 million to people who will get the best score in something. And here you can see when they later evaluated what actually happened, they actually didn't implement the winning solution just for the same reasons that I was talking about. That it was too complex, too brittle, so it wasn't worth actually putting it into production. So from the business perspective, yeah, they got the highest number. They got the SOTA, but yeah, it's not what businesses really need most of the time. This one is a little tricky. So I'll probably start with the image. So how to articulate this? So there was a discussion about language identification. If you don't know, you have a piece of text and you want to determine what language it's in. So we're discussing some tools which are good, which are bad, and when. And then this tweet appeared that really made my blood boil, that it's a solved problem. Because that's so untrue, and it shows a sort of lack of understanding of the context, because it's not solved in any. It's solved in the sense that if you have 20 languages and you're choosing one of them, then that's kind of okay. But what happens in reality, you don't have 20 languages. It's possible that the text is in some unknown language. It's possible that it's in multiple languages, happens all the time. There are various other axes, like do we need confidence with the prediction? Is it maybe short text? Do we also want to segment the text according to the language blocks? So there's a lot of stuff that is not really solved. And the point is that this sort of definition of what is still worth, when we're just chasing the numbers on a problem that nobody cares about, versus when we should move to a different formulation. I call that the problem overfit. It happens in research. Probably if you come from engineering, you don't know what I'm talking about, but it can happen that in research you start building a complex solution and chasing these numbers, but you get lost in the symbolic logic and you detach yourself from reality. So you need this input, this steering from feedback of what is worth doing. So and this is where industry is super important. That's one of the main advantages. They have the subject matter expertise, so they know they can say something that the research cannot do, like, we don't really care about this error, it makes no difference, so it doesn't matter if you get 50 or 60%, it's relevant. We care about this part of the data or these types of errors. And this type of steering is absolutely critical, and that's something that the industry doesn't realize they have this power, like they already have this knowledge of what's actually useful, the utility and the difficulty of where should go. One well-articulated business problem can launch entire research disciplines. I've seen that happen. So it's really important for industry to provide this feedback and guidance on what is important. How can that happen? Joint projects, basically. Well, two ways. One is joint projects, which we also tried. It didn't really work that great for us, but there's a small sample, so I don't want to extrapolate from that. And another thing is companies are starting their own research departments more and more. Before it was just the huge companies that have these research labs, obviously, but there are millions of other companies around the world who don't have research departments. But more and more go this way exactly for the same reason. They can define the problem, and then they can maybe chase the SOTA, chase the numbers, but the numbers are meaningful to them. It's not just self-serving optimization. How am I doing on time? I want to show you. It's fine. So, and this stuff that big companies can do. We're not a big company, so I'm kind of, I'll be brief here. But I think they're doing a great job. I think what should be happening is that they should lobby for the incentives to change, so that the academic careers are not evaluated just on publications in some arcane publishing systems, ossified, sort of weird things, but they also appreciate the tools, the repeatability and the quality, and there's less pressure on publish or perish. That can happen through big company lobbying. And also what they're doing is reducing the dependency on this academic career. They're opening other options. You can go and do great research at quite a few companies now, big companies. So you're not that limited. You have a lot of freedom there, and you can do your thing, and it no longer matters so much that you publish a lot of little incremental weird papers all the time. So that's my sense is it would be a long discussion. I'll probably skip that. And they're also putting their brand name behind some open source and some projects that are beneficial, sharing infrastructure, software, cross-pollinating with research across companies, publishing what they find in the industry and so on. This is the final slide. I was wondering whether to include it because it's a little fuzzy. But it's a bit like in the Monty Python, the comedy group behind Python, the language, where they have in the meaning of life, they give this advice of don't eat too much fat and walk a little, exercise a little, read a good book, be nice to people. So it feels a little underwhelming, but I find this is really important also. You can get all sorts of fights between industry and academia versus the legal and so on. Everybody makes fun of the other side. People live in ivory towers and do stuff that's not interesting, and marketing and sales, they get a lot of flack. But because I wore a lot of these hats, well, I wore all of these and quite a few more, I can tell you that everybody's trying as hard as they can. So maybe it's hard for different reasons, but it's showing respect is a great way also to build the bridges, because everybody's really doing a hard job. None of these things are easy or easier than the others. In any fundamental way. Great, that's just a summary. Let me skip that. I want to get to this one. So if you want the summary, the slides will be probably online. So it's what we already talked about. But what I want to show you today, I want to announce a new open source library that we're releasing today. You're the first people to hear about it. We call it Bounter. So what is Bounter? I think everybody knows Counter. That's a new, relatively new built-in tool in the standard library of Python, where you can count the frequencies of things that happen. So you give it some objects, and it counts how many times did each object appear. It's fairly well optimized, and this is a task that's useful across the spectrum. It's when you're analyzing logs, when you're building your dictionaries for your machine learning models, and all sorts of other places that this crops up. It's a pretty fundamental task of computer science. Now, the thing with Counter is it actually uses a lot of memory. So it's good at what it does, but it's too generic, and we can do better if we optimize a little. What I mean is, for example, in collocations, which is one of the tasks in natural language processing, you want to detect sort of multiple tokens, like phrases that should be treated as a single unit, because you don't want to split your company name into maybe 3 words. It should come as a single unit. So, and you want to do this automatically. You want to detect which phrases are these collocations that you want to treat as a single unit. And in order to do that automatically, there are several techniques, but what they do is they need how many times does the phrase appear as a whole versus how many times do the constituent tokens, let's say, appear in it. And then it does some math and says, yes, no, it's a collocation or not. That's not interesting, but you need these counts. So that's the connection. Okay, and if you want to do this for large corpora, because that's where you want to find these collocations, so you have a lot of these counts and the statistics are reliable, you find that things like Counter take too much memory. Okay, on the Wikipedia, I have some numbers here. They're like almost 2 billion bigrams, so two tokens next to each other. And it takes a lot of memory because there's a lot of overhead in Python with the objects, so there's like an extra, I forgot what, 24 bytes for strings, extra, 16 bytes for integers and so on. And we can actually do better by using approximations, by using a smarter algorithm. And that's exactly what Counter does. So let's finally coming to what Bounter is. It's just like Counter, but you can get the counts in bounded memory. You say you I have 1 gigabyte, and I can get the counts in just 1 gigabyte instead of 31 what the counter would need. It's optimized library in C, so it's actually faster than the Python dict. It's faster than counter at what it does. And that's a little example of how you would use it. You use it like counter, but you say the size megabytes equals 1024. You can see there. So you say, I only want to use 1 gigabyte of memory, and in that, do all the counting, and then it acts as a counter. You can get the frequencies after you fill it with objects. It actually has 3 layers of functionality, because what we found is there are multiple, this is research at its best. There's actually great research on how to do this efficiently. So the algorithms are very smart. Like there's the hyperlog log, which lets you just count how many distinct items are there in the collection. Okay, like one operation, basically the cardinality of it as a set. So that's a beautiful algorithm that we implemented. It doesn't let you do anything else, like ask for the frequencies of individual items. That one just gives you how many unique items were there. And you can do this just surprisingly, just in a few kilobytes, even for billions of items. So this is really some well, not magic, but it looks like magic going on. The second layer, if you want to actually know how many times did each individual item appear. So for example, the word Python, that sort of operation, you need a different structure. So here we implemented count means catch, another beautiful algorithm that does it super efficiently. And that's how you can fit so much information into a bounded amount of memory. So that's count means catch. And then finally, the widest range of operations that it supports is if you also need the keys. It's a little bizarre, because in the second case, you can ask how often does each item, each string appear. But you cannot enumerate which strings are in there. It just tells you, you give it the string and it tells you how many times, but you can't say which strings were entered into it. And that's what the third layer does. It also lets you enumerate the keys and the items, just like a counter or a dict. It's the most memory intensive, so the ones above sort of support less, but are more efficient. So with the same amount of memory, you can do more data. And yeah, that's an example there. So how does it actually work? We did it we tried on the collocations, just like I mentioned. And here you see some numbers. I like numbers. We're not chasing SOTA here. It's just a little table. So the top line is the counter. So on Wikipedia, or is it too small? I'll read it for you. So it's 31 gigabytes of memory that it needs. It finishes at about half an hour. And it gets an F1 score of 100%, because that's the ground truth. It's exact counts coming from counter. And then if you want to get 100% with bounter, you would, I don't know if I can show it, but in the middle, you see the 100% there. You give bounter 1 gigabyte of memory, and that's enough. It also gets to 100% accuracy, so it doesn't miss anything. 100% precision and recall. It takes about 20 minutes, so it's quite a bit faster than counter. So you lose nothing pretty much. And then there are a few other cells where you can see with 4 gigabytes of memory how it works. And interestingly, because you can say how much memory you want to give it, so you can say, what if I give it just 128 megabytes? So very little memory, like, what is it, 200 times less than the counter. Well, you still get 96% F1 accuracy. So there's this trade-off between how much memory you give it versus how accurate the counts are. And for many tasks, it's good enough. Like to have, with the collocations, there's no hard line where to cut it. So okay, let me just finish. So I'm actually pretty excited about this library because it's so useful to us. So what will be happening next is we will be replacing a lot of the functionality that we have in our libraries like GenSim with Bounter. Because what happens everywhere is you first need to scan the vocabulary, then do some filtering based on the count, and then you build models and so on. So all of that will be done by Bounter soon. So we're pretty excited about this. It's already released, so you can get it from the usual places. pip, it's on GitHub. If you want to have a look, it's open source, MIT license. So if you find bugs or whatever, just let us know. And I think that's really the end of my talk. Thanks for your attention.
Thank you, Radim. We have time for 2 short questions. Okay.
bit of a silly question, this one. How did you come up with the name Bounter?
It was an internal vote in our company. So we're democratic like that. So no, what it means is it's like counter, but memory bounded. So like bounded counter. Yeah, sorry.
Okay, second question.
My question is, does this drop in accuracy, is this drop in accuracy resolved in any special way, or is it just, or does it just depend on the data structures you used? I mean, does it, for example, underestimate big counts or underestimate small counts? Is it guided in any way, or it's just, you know, using the appropriate probabilistic data structure?
Yeah, there's actually quite a bit of engineering behind it that I didn't go into, but these algorithms, like for example the count means catch, they have some internal parameters like the width of the hashes that they use and so on, and these are set automatically when you say I want one gigabyte or something. But there's also like a power user mode where you can go in and do these trade-offs manually. So what sort of accuracy? There's also a mode which I didn't talk about, but you can represent actually counts not as integers, but in a probabilistic way, which is it's really bizarre, but in like 1 byte, you can represent a whole range of numbers up to 4 billion or something like that. Okay, with less accuracy, so you save, you know, in 1 byte, instead of 256 values, you can do 4 billion values, so it's kind of weird. But again, it's a trade-off with accuracy. So there's a lot of these little tweaks if you're really interested, like for the power users, and it's in the documentation.
Can I have just one question? Thanks for a great talk.
Who's talking?
Yeah, I'm here. On the left, here.
Oh, yeah.
Hi. Thanks for a great talk. So I'm actually a bit of a similar situation. I live on a intersection of science and business, and I think that science started to realize that figuring out the better results at a lot of conferences is not the way to go. So there are more and more conferences that are actually appreciating the work and not only the numbers.
Yeah.
But from your experience, what's the best way of collaboration between academia and research? Is like research grants that have no strings attached, or is it like joint ventures or outsourcing some work to the universities? Because getting the better results and expecting the academia to provide out of the box solutions for business is not fair either, because this is public money and here is privately owned companies. So there has to be some sort of a collaboration going on. But what's the best option?
Yeah, for us, I mentioned it didn't really work. Yeah, great question. But for us, the collaborations didn't really work, mostly because we operate at a different frequency, different pace. So like direct collaboration wasn't great. But what really works is growing the talents and the workforce. That's what I'm, I guess, the happiest about this incubator. It costs our time, like we're doing it. It's for free, this mentorship. The students don't pay anything, we just do it for them. Same with the open source, you can get it for free, but it costs us money, obviously, and effort. So like educating the workforce on how things should be done, we think that's the best probably return on investment that we have. We don't expect any direct, like you say, products coming out of academia. I'm a simple person, I like simple things. So you saw what I recommended, just put some locks in there, so it's not completely, a little sanity check goes a long way. That's our expectation. Yeah.
Thank you so much. Thank you, Radim, for your talk. And I feel really honored that you have announced this library during PyData Warsaw.
Oh, there's one more thing I wanted to mention. So we have some open source stickers up here. So if you like that, come get some.
We can move the stickers during the break to non-focus table over there. So we can. There's a bunch of stickers over there, so we can pick them up from this table. So yeah. Big applause for Radim.